Evening, folks. This is a delayed video. I know it'll post probably on 4th of July, but I did it a while back. Anyway, I was working on Dometic. Remember I showed you on the other video how I did the absorption unit and changed it all. Well, now I'm going through some troubleshooting procedures. It all works, but I just want to teach you why I got it out. All right, so let me show you something a little bit different about Dometic on the two-door series. Which I think is a 2652. Hold on, put you on. Yeah, 2652. All right, so what I did is, since I don't have the doors here, they're in the fifth wheeler, and we had to take the doors off to get it out. I put the styrofoam up here in the freezer, and it started out at 80 degrees. It's 62, and that was in less than an hour. All right, so I feel a little coolage leak, but not much. And then I foamed this in, which is your refrigerator, right? And the fins. All right, so that's just to run it so the unit don't overwork. All right, put you on hold. I'm gonna get right back over there. Okay, so a lot of y'all are asking questions like, well, how many amps does this thing run? Well, it uses 12 volt DC from your house batteries and your converter or slash inverter converter. Remember, there's a video on that, school times called ST, and then FTC from the chair. Okay, but now let's get back to this. All right, so I'm gonna show you how much amps. This is just using the relay for the 120 heating element. All right, 120 plugged in. Right here, that's 89, here, let me turn the light on. 89 milliamps, all right, here's 20, which would be OL, and it went off because it was OL. Ready? Now listen. Okay. So it's 89, about 90 milliamps, which is 0.090 of an amp. It's 9/10 of an amp, basically, okay? All right, so everything's going. All right, now we're going to see how many amps the AC side. Did this on another one, a Norcold, no code. It's 2.63 amps AC. See the squiggly line there? All right, it's on the 20 amp scale. So that heating element is the right one for this. Now all you gotta do is take 26 amps divided into 120 volts, E divided by I, right? Or P watts equals E times I. All right, so we know the amperage, we know the voltage. So there you go. 26 times 120 tells you how many watts that is. All right, so what I told you, E is a constant 120. Yes, it'll drop down to about 108 on a severe load, but not on this device. It shouldn't, unless your shore power drops out or your inverter starts messing up. All right, so we took the amps that we put on a clamp on amp meter, 2.63 under amps or I, E times, not an X, that's a dot, E times I equals 315 watt heating element. All right, so that's right. You have to look these up by each model. A lot of y'all are doing the generic, oh man, I got one on Amazon for $12. Folks, don't do that. Get the right model, pay the right money, because each model is a little different. If you get too less of wattage, it don't boil fast enough. If you get too much wattage, it overboils. And we know what happens there. We can go, boom! There you go. All right, so let's not do that. All right, so that was a basic check there. Right? And remember, that's the DC amps, okay? That's not bad. All right, now what I'm gonna do is I've unhooked the light, because the door's off. So I'm gonna show you what happens to the amp draw when the light's on. Notice how it says lamp/heater. Well, lamp is to the left because we read from right to left, top to bottom. So we put it on there. Okay, it went overload. All right, so I'd have to put this on a 10 amp scale. Hopefully the 10 amp fuse is working. There you go. It's 800 milliamps. All right, that's the lamp. Okay, 830. So I'm gonna disconnect the lamp. it dropped it down back to 80, 90 milliamps, okay? But to get an accurate more reading, we lower the scale. We always start out with the high scale, okay? So I go back here, and it lost voltage because I'm in series. Go to 200 milli. There you go. See what it? 63. It's more accurate. All right. Well, there you go. 89. That's what I told, about 90, but 89.5 amps, or milliamps, 0.089. Okay, the next thing we're going to discuss on this is how this board's supposed to say, oh my God, I lost 120. I was hooked up to the shore power and it went out, or the generator died or shut down, or the inverter stopped inverting, which takes DC voltage, makes AC voltage, which the heater element works off of. There are some 12-volt heater elements out there, but this is a 120-volt AC. All right, so we're going to watch. All right, first we'll do the series, the test. All of you say, hey, man, we're going to go down to the beach. We're going to be down there all day. And you trust them RV camps to keep your refrigerator fired up. So what you do is you go out, and right about here outside is a 120 outlet, right about here. So here's that plug. So when you disconnect this, you're going to hear a couple relays click. You're going to hear this ignite. The gas valve right there is going to energize, and the gas is going to flow, and it's going to flip over automatically. Notice the word I said, automatic. Ready? Okay, here we go. Wait. Shh. Oh, I gotta turn the gas on, dummy. See how quick that was? Now, the DC amps went up. Now, that was automatic. If you're not checking that, you're not doing a preventive maintenance check. All right, you need to do it once in a while, because that part of the circuit you can mess up. Now, notice the DC amps went up because now we're energizing this relay coil. It takes amps. So I'm going to put it on. It'll go out. Don't worry about it. It'll come back on. All right, there you go. Took DC power away from it. It's going to say, hey, I don't have no AC. And it's going to click, bang, boom. All right, wait. There it goes. Sorry about that. All right, so there you go. Now we're at 3. Now, while that's running, if you're on propane, for y'all that want a boondock or whatever, you're 290 milliamps. You went from about 90 milliamps, 0.090, to 290. It's almost 300 milliamps. That's a third of an amp, basically. A little bit less than third, okay? Backlight, there you go. All right, now, the other thing we're doing is this Dometic has a separate igniter system. And how it get activated is you have the yellow wire gas valve coming from here, valve, relay, white is power, it's a pull-up, and this is ground. And it feeds the same voltage over to the igniter, which has a built-in timer in it. It says, all right, click, 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 boom. Now, this has what we call a rear thermo sensor in it. I'm going to get a little flat tip screwdriver, put you on hold. Okay, so what are we testing? Right in there. That. You see how it's in the flame right there? It's getting hot. That's generating a voltage. That's this wire right here. It comes back, goes over to here, and it's right there, the flame sensor. See what says flame? Now, let's say the problem is this. It ignites, burns a little bit, and goes out. Well, that flame sensor I just showed you probably dirty. You got to clean it off a little bit. Don't get crazy and scrape the living heck out of it. Just clean it off a little bit once in a while. Preventive maintenance. Because propane is dirty. It is got a lot of high moisture content. All right, and it creates rust and corrosion. There you go. All right, now we're going to do the voltage check on this. This is a good voltage check for a flame sensor, not the igniter. Some of them use the igniter to do it. Feedback. This don't. All right, this don't feed back to there. Okay, so put you on pause, get the multimeter set up, and show you how many volts it is. The flame sensor voltage tells the power board, hey, there's a flame, keep the gas valve solenoid activated. This one only has one, and I think it's at 40 ohms. Put you on hold and I'll set up. All right, here we are. Turn it around. We're getting 33.2 millivolts. We are on a 200 millivolt scale. See it right there? 200 little m volts DC in blue. All right, there I am on flame sensor and ground. Okay. The reason why you're seeing negative, because it is a negative voltage. The positive lead is on the negative side of that circuit. But don't worry about that. You're reading about 33 millivolts, 0.033 volts. This is a good flame sensor. Now, when they get corroded and covered, that voltage drops down to 20. So once it goes about below 20 millivolts, 0.020 DC voltage, it won't work. All right, so it could be a defective thermistor, or excuse me, flame sensor, and it generates its own voltage. All right, it has a bias circuit in there, but let's not worry about all that. That's the voltage that you need to see. All right, so that was that circuit for you, okay? One, let's go over it. One, you saw how many milliamps that the system drew, okay? On AC, it was a lot lower amps, like 0.080, under 90 milliamps. Then you turned the light on, you saw it go, whoo, a lot of amps were drawn. Then we converted it over from electric 120 heating element to gas, and the amperage went up. On the DC feed side, 12 volt. That's for y'all that are boondocking. Y'all to hook up to 120 all the time, you don't have to really worry about it, all right? But you do in a way, but you don't. All right, so anyway, this is Jeff from Rvdiagnostics. Hope you learned a couple things here. If you did like the video, give me a thumbs up and subscribe. And also the other thing is, put some comments down below. Hey, Jeff, what'd you say that was? Because I make mistakes making my videos every now and then. But anyway, thank you very much. This is Jeff from Rvdiagnostics. Safe travels, and may your campfires burn bright.